good afternoon, class. The topic for this afternoon is operational amplifiers. So what are operational amplifiers? Is this the first time that you have heard of this electronic device? Type 1 daw sa chat day kung first time pa ni. Kung dili pa, kung dili na, okay ra, no? I mean, kung first time pa, okay ra. Kaya kayo if wala pa kaila or wala pa tayo information regarding op-amp. Okay, so ang uban is dili pa first time. So thank you, no? Dagan-dagan mas lang nag-respond o first time. Alright. So alos kita tanan. This is the first time that we've encountered an operational amplifier. So what is an operational amplifier? Why is it named as such? Anong operational siya? So it is an amplifier because, well, whatever ato iputang sa input, mas productive niya ang voltage level to the amplifier. But what does operational mean? What kind of operations are we talking about? So later, ito na siya ma-answer ang question. So basically, an operational amplifier or op-amp is a very high gain differential amplifier with high input impedance and low output impedance. Simply stated, that's it. No? Maragin na iyahang basic working definition. Very high gain differential amplifier with high input impedance, few mega ohms daw, and low output impedance, less than 100 ohms. So this is the electronic symbol or schematic symbol for the operation amplifier. Nakahigda na triangle. Sa input na side is na idwa ka terminal. Sa output na side is na isa, the output. Some schematic diagrams use this symbol as a more conventional na figure for op-amp. Nasa taas ang negative symbol. So although dili na sila interchangeable, lahi gid ang positive nga terminal sa negative na terminal. Pero mas conventional, anong maong gigamit sa kanina slide. So mas conventional is supposed to be ang negative is nasa taas. Positive dapat ni dire. So, okay lang na siya. Interchangeable lang siguro siya in terms of sa pag-draw. Pero distinct as lang duha, no? The input 1 is different from input 2. If natay gusto ibutang ka input 1 na signal, pero i-draw na to sa inganing klase nga signal, dapat dito lagi po siya ibutang. Okay. So, input 1, input 2. Let me label. So, the input designated as positive is what we call the non-inverting input. So, it doesn't mean na positive lang ato ibutang diha. Or we do not call it also as positive input. No, we call it as the non-inverting input. One ang iyang proper name. And the input 2 is the inverting input. That's the proper name. So the non-inverting input and the inverting input. Ang output is output na siya. So look closely sa atong pang-underline sa definition. No? Iyang 3 most basic na characteristics. Very high gain. So we could say nga iyang voltage gain is approximately equal to infinity. Very high input impedance. And very low output impedance. So basic definition, ang kaning nga mga parameters are very ideal. Diba? Very ideal conditions. We'd want our amplifier to exemplify these parameters. High gain, high input impedance, or low output impedance. So sa may implicate, sa may significance sa high input impedance and low output impedance. Kaya na to necessarily expound ang high gain because kapag naman taon sa implications kung high ang gain. So lako yung paano voltage or power raising capabilities. But what about high gain? What does that mean? What's the implication on that? Say significance or zero output impedance or very low. I don't know approximate. I don't think exactly zero, but very high and very low. So high input impedance means that if you try to imagine na dako kayo diri nga resistance, resistor ZI, that would mean no amount of current will flow inside our system, or inside our operation amplifier. So no external current can influence the internal circuitry of our operational amplifier. Ang current level, at least sa atong signal, will not influence our operation amplifier. So isn't that a very good capability? Yeah. So the opposite is true for the very low output impedance. We'd want our amplifiers, or we'd want our ideal amplifiers to have zero output impedance, such that if zero yung output impedance, that means all current na kaya i-output sa atong system, in this case the operation amplifier, is magawas din sa output. Okay. So there's nothing sa output side na mupugong, no, or mo impede, no, mo resist sa flow of current to whatever output device ato i-connect sa operation amplifier. Meaning kanan energy, kanan current is mo flow sa load. Again, we'd very much like our ideal amplifier to have those characteristics: high input impedance and low output impedance. So that's so much for the impedances. Now, how about the gain? So op-amps have a very high gain. And we have two types of gains, the closed loop and the open loop gain. Open loop refers to a configuration where there is no feedback. In the open loop gain, the open loop configuration, the gain can exceed 10,000. Ang ato ganing approximation niya is infinity. Sige, more practical na lang siguro nga number, 10,000. Imagine we have an amplifier having a gain of 10,000. Is that something na makaya na to comprehend? 10,000 voltage gain? What does that mean? If lugar natay input na only 1 volt, does that mean that our output is also 10,000 volts? Would you agree nga ingani yang makaya?
Dili sir, like naigya po limitations depende lang sa DC na source.
Okay, very good. So I think na cover na to gyapon yung question before, right? Yang main limitation good is ang DC nga source, of course. So even if our op-amp has a very high gain, 10,000, and mo input lugar tag 1 volt, ang kaya lang niya i-output is its maximum voltage supply gyapon. So very good. Thank you, Nico. Nico ba to?
Yes, sir.
Okay, thank you. Nico? The output is still approximately equal to the maximum supply voltage. So, I hope nakadumdum gyapon ta na, guys. That's a very important na concept, not only for op amps and amplifiers, pero for all, no, electronic devices, electronic systems. Kung gusto tayo na ay something interesting may tabo sa atong circuit or na siya particular nga function, we do not want it to saturate. Saturate na may ang tawag ana, di ba? Maabot siya sa saturation point. So again, malimit noon sa supply ang possible output sa atong operation amplifier. But again, that doesn't negate the fact na close to infinity gid iyang voltage gain, no? Very high voltage gain. So using the open loop capability of the op amp, there's no way for us to control the gain, no? Even kung yan naman galing, dili na to ma-control pod, no? We cannot control the output of our op amp because like katong iya to ganina, ang nag-influence na noon sa output sa op amp is ang voltage supply, ang maximum voltage supply, no? So in the open loop configuration, diba? Naman noon direct, no, naman sa slide. Sa open loop configuration, ma-fully utilize ang very high gain sa op amp. But for us to control, we do not want our op amp to have, if we do not have our op amp to have that high level of gain, we could use a closed loop configuration using feedback. A closed loop configuration, ang iyahang trade-off, pero in this case, favorable man siya na, favorable man siya nga trade-off, it reduces the gain. Pero gusto man po na yun nato nga i-reduce iyang gain. Okay? The closed loop configuration reduces the gain. So, for what? For ang trade-off niya, na-reduce ang gain is reduced, for us to have control. No, na-increase kibali ang atong control. Pero for me, positive manis lang duha ng mga kuan. No, di man siya technically trade-off yan. Pero ang trade-off, no, quote unquote, ang trade-off sa pag-lower sa gain is na increase ang atong control sa gain. No? Pwede na nato ma-program, sort of ma-program or ma-set sa atong choosing or liking ang gain sa op amp. So in order to control the gain, it must have a feedback. This feedback is a negative type of feedback. Negative feedback reduces the gain and improves many characteristics noon sa op amp. No? Pagkaayo ka ng very much favorable gin sa ato, although na-reduce ang gain, na-improve na noon ang many other characteristics sa op amp. But then again, gusto man gid sa nato nga i-reduce ang gain. No? We do not need our op amp to have this amount of gain unless for another specific purpose. May mga instances nga kinahanglanon ginato ni. But for more useful applications, for more interesting operations, we'd want to lower down our gain. So I think the next few slides is the type of circuits na itong pwede mabuhat sa op amp. So the very basic circuit that you could create using an operational amplifier is the inverting op amp. Inverting operational amplifier. So sa inyo kayang circuit, no? Ngayon lang. No? That's it. Sa inverting input, we just connect two resistors, R1 and RF. The other terminal ni R1 is dili na to i-insert atong signal source. The other terminal ni RF is connect sa output. So this is the negative feedback. It's called negative feedback because somehow lower down or mag-degenerate. Mag-degenerate ang ideally high gains of an operation amplifier. That's why it's called a negative feedback. Kaya lang, no? Mura na siya. Ang kwan lang ani, another characteristic sa inverting op-amp, and the same mangyapon no, sa regular BJT amplifier, is that i-invert po niya ang phase sa input. If ang atong input signal is like that, atong output, although na-amplify, but na-flip 180 ang kuan signal. Okay. That's the inverting amplifier. So tungod sa feedback resistor, it lowered down the gain. Reduce considerably ang gain sa atong amplifier. How much? Will no, maybe there's a formula to compute for the gain. For a while. So gains can be determined from external resistors, RF and R1. So here's the formula now for the gain of our amplifier. At least for our inverting operation amplifier. AV is equal to RF over R1. Negative yun dapat. Negative RF over R1. So let's say for example, RF is 1 mega ohms and R1 is 100 kilo ohms. So hindi na infinite ang gain sa itong op-amp. Okay. But how much naman? Simulay gas calculator. Pila gain ani class?
Negative 10,000, sir.
10,000. Mega ohm man kani kilo ohm. 1 million divided by 100,000.
Kung sa negative 10.
Wala siya, no? Very easy. Now, what if our RF feedback resistor, that's why RF yung tawag, is a variable resistor from 1 mega ohm to 2 mega ohms. Sabi itong liso-liso nga resistor, no? Masyagana na yung knob. Pwede na ito mapuyok-tuyok. Ano yung mga terminal dyan eh? Free terminal na ng potentiometer. I'm not sure if you've heard this term. Potentiometer or variable resistor. So if potentiometer nito o kaning RF or feedback resistor na mag-vary ang value from 1 mega ohms to 2 mega ohms, pwede po dahil nato ma-vary ang atong gain, no? So pwede siya mo yung variable gain from 10 to 20 again. Sakto, di ba? Yan na kayo, no? Yan na lang. No? That's how we compute the gain. Does the operational amplifier have so potentials are loaded, unloaded, or with source? So no need na because wala na yung absolute na gain. Because remember, yung input impedance is infinity. If equal na to si RF and R1, let's say si RF is also 100 mega ohms, si R1 is also 100 mega ohms, we have a unity gain nga amplifier. Constant gain RF is multiplied by R1. Okay. And I guess that's it for the inverting amplifier. Wala kayo din computations and formulas with regard to its gain. So there's a concept that we call virtual ground with regards to the analysis of op-amp for us to obtain the gain, no, of all the other configurations for op-amp. Kailangan pa man configurations other than the inverting op-amp. Okay. So the concept of virtual ground is most important for us to derive the formulas. Okay. So in a bit of a nutshell, may lang ato ikon ani because we do not need to derive ganit the formulas for all the other configurations. Kasi na lagyan mo sa memorization. This case, parang di na sila tagay need mag-refer of table. But if you have a copy of this slide, pwede na nito mag-serve as our copy for the formulas. Pero again, for us to derive those other formulas, or those other formulas were derived using this concept, the concept of virtual ground. So what does this mean? So effect ni siya sa fact nga, again, our op-amp has no wala siya tungkol kay high ang input impedance, wala current na flow sa circuit, okay, sa system. Again, input impedance is infinity, meaning the current that flows inside our op-amp is 0. So meaning, whatever is the amount of current that is flowing here, that is also the amount of current that's flowing here. Let's say I1 and I2 na siya. So I1 is equal to I2 then. And based on nga concept, yeah, nato na derive ang formula ani, no? Asa ni siya gikan ng formula. And virtual ground siya because it is as if there's a ground that's connected to this node. Diba? If a node is connected to ground, meaning ang voltage at that point is 0. Okay, so because all current is flowing in this manner and no current will flow inside, it's as if this node is connected to the ground and there is 0 voltage at this node. So kana lang atong need, no, mabalaan, because again we do not need to derive the formulas for all the other configurations. State na nato daan doon. So because of all those concepts, negative feedback, virtual ground, okay, high input impedance, low output impedance, we could create more practical operation amplifier circuits. We've covered the first one, inverting amplifier. There are also others: non-inverting amplifier, unity follower, summing, integrator, differentiator. And we will learn as we progress, no, for the coming days and weeks. Kadaghan pati kayo applications ang operational amplifiers. Kasi non-BJT, kaya naman po siya application, sa amplifier natin na cover. Ang op-amp mismo, at its most basic na configurations, kailangan siya makaya, no? kanya alone. Ang mga basic lang sila. All the other op-amp applications or circuits apart from what we see now ay more complex. More complex lang. For the inverting amplifier, with this formula, ang non-inverting amplifier, if i-compare na to ang formula, aside sa na positive, ay plus 1, no? Yan na. Wala lang na bago. So, if mo na yung formula for the inverting amplifier, pag plus lang tag 1 here, ano na rin siya ang formula sa non-inverting amplifier. So, as the name suggests, non-inverting siya because whatever is the waveform of the input, the output is just an amplified version of that one. Same na gap of phase. Wala kibali na invert. No? That's why non-inverting. Wala na-invert ang output. So this is the circuit for the non-inverting amplifier. No? That's like similarities. Because actually they really are. No? They really are the same circuit. Dili gani kay lahi pagka-draw. Pero tanawan niyo class. Basig mas malibog ta kay gitransfer niya ang non-inverting sa taas, no? Negative sa silong. Pero kung gi-retain niya nga manner, ang difference sa inverting o non-inverting is if this is an inverting op-amp, ang non-inverting is nadiri ang ground o nadiri ang input. Observe. Pareha na ba ang akong gidrawing sa left to right? Notice nga wala na ako gi-flip ha ang sequence sa plus or minus. Would you agree nga these two circuits are now the same?
Yes, sir.
Yes, question mark? Or yes, period? Or yes, exclamation?
Yes, sir.
Wala
Yes,
na, di
period,
ba?
sir.
Yes, period. So para dili libog na mo, naglibog-libog man nga author good. No? Gibali niya ang plus or minus para mabalhin ang mga resistor sa silong. Pero if ang iya lang gibalhin is ang mga source ug ang ground, iya lang ning gibaylo ang duha, nanatay non-inverting op-amp. Para bitaw malagdili kay daghan nga circuit atong gi-memorize. Isa lang gihapon, isa lang ka klase nga circuit, gibaylo lang ang source. So, same na gyapon, no? The same na ang purpose niya, inverting o non-inverting input. Inverting o non-inverting amplifier. I-amplify ang signal sa input with whatever nga gain ang nasa amplifier. And if the ratio of RF and R1 is very large enough, pwede lang ganit ni ma-ignore kaninga 1 and the same as like formula. So paired sila, pareha na sila o mga circuit and formulas. Almost pareha. Another one is another term for the unity follower is the buffer. Whatever yung signal sa input, ipapass through lang yan sa op-amp. And maulagya po ng itsura sa output. No? In terms of voltage level, VO is equal to V1. If DC voltage ang V1, wala po lumaga sa VO. Kasi form sa signal sa V1, mo po ng form sa signal sa VO. So what's the purpose of the unity follower or buffer? That's sa may mga paani. So one of the its uses is for circuit isolation. So at the circuit level, if we want one part of the system technically separate from the other, because let's say for example, another purpose mo put sa amplifier is for protection. So mabuhat lang na siya because of its function na isolation. Let's say for example, we have a more sensitive circuit right here. More sensitive circuit, maybe ang mga internal circuitry is made up of more expensive na components, and we have a sensor right here. Now we perceive our sensor to produce an erratic na signal, no? Unpredictable and sometimes destructive, and dili na to siya directly connect sa more sensitive na circuit kasi maguba pa lang niya, diba? So how will we connect the two without compromising the security of the more sensitive na circuit? Ito mabutang og unity follower or buffer. Yan na. Para in kaso, si sensor is mag-output og destructive na signal, si unity follower lang maguba. Hindi mo lahos kay more sensitive na circuit. So that's one of the purposes of unity followers. Another one is the summing amplifier. Whatever voltage level sa input, the output will be the sum of those inputs. So VO is somehow equal to V1 plus V2 plus V3, so on and so forth. So ang summing amplifier is wala lang na-restrict og tulo ka input. Kung gusto ito upat, pwede na kain eh. This is R4, then V4. There's no limit to the amount of input na itong pwede butang sa summing amplifier. Ito na R4 diya, ito na R5. Basta kay ang output is the amplified sum of the inputs. So each individual branch could have different amounts of gain. Pwede lahi ang gain ni R1, pwede lahi ang gain ni V1 sa gain ni V2 at sa gain ni V3. If dili pareha si R1 ug R2 ug R3. Lahi mo sa formula. Now, what if parehas na to, no? So for example, RF is indeed equal to R1 equal to R2 equal to R3, so on and so forth. Therefore, the output is just directly the sum of all inputs. Okay, one naman ang gain the individual na branch. Okay? Wala lang, no? That's it for summing amplifiers. No? Remember lang na after amplifying each input signal and obtaining their sum, ang final na output voltage is naka-negative. Kaya inverting mangudyapon niya siya na type of fire. So you also have integrator. The output is the integral of the input signal. And differentiator. The output is the rate of change of the input signal. So integrator and differentiator. So integrator could be used as a low-pass filter circuit. Okay, low pass filter. And ang differentiator is high pass filter. Pero it skips not karon because we'll be dealing with filters much later pa. So this answers the question, why is the op-amp called as such operational amplifier? Because ang operations nga iyang ma-perform are the mathematical operations. Ang super karaan pa gid ng mga analog electronic computers that could perform scientific calculations are made up of these kinds of circuits. Perform of operational mathematical operations. So we'll end here with regard to the different op-amp, practical op-amp circuits. Ganyan yun ipasahod ng mga specific parameters later. So let's slide out to solve some examples of op-amp circuits. Example, this one. It's the output voltage in this circuit. First also the gain. No? So muna siya. Inverting. The gain is just the quotient of these two. 250 divided by 20. Pwede ba na siya? 5. 12.5. So 12.5 times the input of 1.5, 18. And that's the output nga voltage. VO is equal to negative 18 volts. Questions? Hindi sa ako napag-obtain. Kung directly na ito ni siya gamitan ng formula. VO equal to negative RF over R times P1. Negative 250K over 20K times 1.5. 18. 50 divided by 20 times 1.5. 1.25, I mean. Right, so today, 1 input na 1.5 there. So 250 divided by 20 times 18, sorry, times 1.5 is 18.75 divided by 18. Here, 18.75. Yan na. Yan na, di ba? Kaya solve ang ZIZO. Extreme values man sila. About this one. What's the range of voltage gain adjustment? Voltage gain. Okay, voltage gain adjustment in the circuit. So, as what I have mentioned earlier, this is what we call a potentiometer. Nothing more than a variable resistor. Yung value ranges from 0 to 10 kilo ohms. Natay duha ka voltage gain nga makuha. One from each extreme values of our potentiometer. So if ato siya i-turn ang knob to the extreme left, so 0 lugar iyahang value. So 0 plus 10 is 10. 500 divided by 10 is 50. 500 divided by 10. 50. So gain din, no? Kung palipod, na ito po i-turn ang knob maximum, meaning 10K ang value sa itong potentiometer. So 10 plus 10 is 20. So 500 by 20 is equal to 25. So therefore, ang atong answer, the gain ranges from 25 to 50. Question number 3. Nasa ko there. What input voltage results in an output of 2 volts? So what if VO daw is 2 volts? That's the input. May gain ano? 1 mega divided by 20. Ang omega, di ba? 1 mega divided by 20. 500. So gain is 500. So the input is 2 volts. The output is 2 volts. So 2 divided by 500. So input is 4. Sakto ba? Check daw. Okay. So 1 mega divided by 20 is 500. If the output is 2 volts, so it's just 2 divided by 500 to get the input of 400 volts. Problem number 4 is the same. No? Ang range lang is ang input. So gain ani is 10. Okay, 10. So meaning output, dapat lang 10. 0.1 times 10 is 1. 0.5 times 10 is 5. So output is 1 volts to 5 volts. See? Ano no? Oh, ato mga kulang guys, mga negative, no? So, the output is 2, the input supposed to be is negative 4. Kasi di pa ng output, so negative sila yung input. Negative na.
Sir, dun
Yeah.
sa pagkuha ang katong 4 millivolts, sir.
I-divide lang ako ang
Dili siya, 20K ba siya, sir?
okay. 1
20K.
mega divided 1 mega divided by
Ang akong gi-bot sir kay 20K over cancer, 1 million. Tapos,
sorry, 50 na day ni.
nakakuha ko
50.
cancer.
Ilan man? 40 millivolts.
Sir, 40, sir.
40. Mas correct din na siya. No? 40. 50 na day ang gain, di day 500. 40, negative 40 millivolts. Okay. So if positive ang output, mas probably negative ang input. Okay, thank you no, sa pag-remind. Kani, negative 1 to negative 1. Positive 1. Check ako ba? 200 divided by 20. Mga inverting man sa naman. This one is a non-inverting problem 5 and problem 6. So gain ane is how much daw? Sige daw guys. Pila gain ane? Try nyo pagkadumdum kanina. Pareha bang formula sa gain sa inverting o non-inverting? May siya formula. So pila na karon ang gain sa atong non-inverting op-amp.
Sir, mag-clarify lang ko, sir. Sorry, sir. 1 plus RF over R, no, sir? Or 1 plus RF over R? Okay.
1 plus, separate ang 1 sa kuan.
Sige, sir.
Ah.
31, sir.
Dili siya i-add sa RF lang, but sa ratio ni RF and R. So if nga na, pila man ang kuan?
31, sir.
1. So if ang question is, what output voltage results in the circuit figure, blah, 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 for an input of negative 3, 0.3 volts. So if muna yung input, multiply lang. 3 times 31. Negative gapon. Okay. Non-inverting one eh. So the output is negative 9.3 volts. Now, but for the next question, what input must be applied to the input of this circuit to result in an output of 2.4? So 2.4 divided by 31. So 77.42. Input should be 77.42. Ignore na sa question number 7. Saktan na? Video 10.67. This one. Same lang ka kanina. So this is our variable resistor. My value is 0 to 10K. Meaning, atong voltage gain is from what to what? Sige daw. From what to what man ang atong voltage gain?
10 to 20, sir. Ah, wait, joke lang. 11 to 21.
Okay, thank you. 11 to 21. If morning input 0.5, the output is 5.5 to 10.5. I think correct na siya. What if RF daw is 330K for this summing amplifier? So better siguro ito calculate ang individual gains for each branch. Gain nga i-multiply kay B1, gain nga i-multiply kay B2, gain nga i-multiply kay B3. See, label natin sila as AB1, AB2, AB3. How much is AB1 plus?
Answer.
330. Yeah, thank you. Divided by 33 is 10. B2,
15, sir.
15. And last,
27.5, sir.
7.5. So, muna mga individual gains. Ipang-multiply na ito sa given. Final answer. Yeah. Meaning VO 0.2 times 10 plus negative 0.5 times 15 plus 0.8 times 7.5. Ang total answer ani is a negative pa rin ang sign. 0.2 10 minus 0.5 times 15 plus 0.8 answer ninyo.
Negative 16.5, sir.
Negative 16.5. False. Final answer. Okay. You could solve this again using an RF68. Practice siguro later. Sketch the output waveform resulting in 1.9. So what's happening here? Ako man eh. So yan siya. So integrator. Okay, integrator meaning output is the integral of the input. So atong input is kung man ang meaning ani is on-off ng 1.5. So integral sa square wave. I think mga answer ani. Integral sa square wave. 0. Ang output is ayan eh. Charge, discharge, charge, discharge. Ayan na siguro. So, kaya siya yun need nga i-activate yun ito drawing basta nga na ang output sa itong circuit. Important lang dito is pila ang gain sa taman. So using the formula, this one -1 over RC. R is 200K. C is 0.1 microfarad. And -50. Okay, so ang gain is -50 daw. Pwede mo siya na maabot. Maximum siguro nga voltage na dito isang supply. Di max sa output. So mawagin nga na ang output niya. Approximate ka na siya. This one, no need to solve. What output voltage results in 0.5. So if 0.5 delay, buffer man eh. So 0.5 ko delay. Ito lang, stages, no? Two-stage amp. What is the first stage? Inverting, non-inverting. So pa ni sila. What is the name of the first stage na of amp? What is this one? Inverting. Inverting. May RF resistor, wala. Paras lagi itsura na sa taas.
Non-inverting na, sir.
Panis taas. Sa man siya. Same ba ang input ug output?
Non-inverting, sir.
Diba na ito siya yung pangalan? Unity follower. Buffer. Diba? So, mo itong unity follower. So, meaning whatever is the input, kasi yung output. So, for about delay, the voltage here is still positive 1.5 volts. And ang atong second stage is inverting. So, muna inverting ang second stage. So, 100 divided by 20 is 5. So, the gain is -5. And the output is -7. Questions, clarification sa item number 12? So, ang first stage is buffer lang klasa, unity follower. But kabalo tanga unity follower siya because tanawa ang feedback wala resistor. So, wala resistor, buffer na siya. Kung sa input, may output. So, if buffer siya, then ang input is 1.5. The output at this point is also 1.5. If ang gain sa atong second stage is -5, multiply na sa 1.5, final output is -7.5.
Sir, pa-clarify lang
Everyone,
yun ko, sir. Kay
Yes.
medyo nalibog ko, sir. Unsa how do we know, sir, kung non-inverting o inverting siya, sir? Pa-clarify lang ko para ako man-note down, sir.
Sige. Medyo, dali naman siguro kasi sa sugod kayo medyo libugan pa ta. Pero okay lang na siya. Ang inverting, okay, mo-invert siya, di ba? I-flip niya. Ang inverting, ang other terminal is naka-ground gina always. Pag inverting amplifier, nasa inverting input po ang input signal.
Okay, sir. Thank you, sir.
Okay? Unlike this one, muna siyang example sa non-inverting. Non-inverting na eh. Meaning, ang sa inverting input, dito nakakonect ang ground. Ibailo na to ni, kasi for example, dili ang ground, dili ang atong input signal. This makes this amplifier an inverting amplifier. So, sige lang, no? Sige sa sugod. Libog pa ta, pero don't worry, naman ko tayo guide ani the slides. This one. Medyo nakapabor lang ang pag-drawing ni Boylestad ani because i-klaro din niya maayo sa inverting and ang non-inverting. So the same yapon sa example sa taas, ang first stage is a buffer or unity follower, meaning the voltage at this point is also equal to positive 0.2 volts. So mo nang i-feed dire na input and dire nga input. Okay? So dili naman sila cascade, nag-separate naman silang duha. At na lang i-solve ang individual na gains. Ang gain niya is 200 divided by 20 is 10. If ang input is 0.2, the output is 2 volts. Silong, sorry, -2. Okay. Dire, negative ang pinako. So, -10. So, -2 na siya. Sa silong, 200 divided by 10 plus 1. So, the gain is 21. So, si 21, i-multiply natin kay 0.2. 4.2. So the output here is positive 4.2. Question sa kaning example. None. Okay, that's
None, sir.
good. Thank you for response. So if wala tayong question, we'll end here. If na may additional nga concerns nga brought up, time nga mag-review mo ani nga recording or video, pwede lang po yung message anytime. But I hope you also understand, no, or appreciate nga multiple times good na pasayo ng atong analysis, no, kaysa sa kung i-compare lugar nato ni sa BJT o FET, di ba? Dali na kaayo, pagsubay-subay na taog mga voltages, no? I-familiarize na nato ang itsura sa configuration ng circuit, and then, well, with that, i-familiarize pa na to ang formula sa mga gains. Pero at least this time, masayon-sayon na ang formula sa mga gain, no? Dali na kaayo. So if there are no more questions, we'll end here.